Hello from Earth. It's great that we have the technology to communicate over such a vast distance. I'm sure you are enjoying the spectacular views of outer space. Once you are out of Earth's atmosphere, the scenery is breathtaking. But did you know that stars do not shine forever? In fact, every star that you see in the night sky is either burning and depleting its fuel, such as hydrogen or helium atoms, or has burned through its fuel already and is now in a different phase of its existence. Burning and consuming a star's fuel is called nuclear fusing. This process is at the heart of the main sequence of processes and transformations. These stars are therefore known as main sequence stars. The main sequence stars are considered to make up the vast majority of stars in our universe. Nuclear fusing occurs within mature stars. Let's learn about what eventually happens to the main sequence stars after they have finished nuclear fusing. To understand what types of mature stars exist, we apply specialization unfolding of mature star. Mature stars can be roughly classified into 4 types: low mass, intermediate mass, high mass, and massive. Our Sun, for example, is considered a low-mass mature star, despite it being more than 1 million times larger in volume than Earth. Stellar remnant is the ultimate product of some of the mature stars. A stellar remnant is classified into a white dwarf and a supernova. So what happens to all these stars? Depending on the mass of the star, mature star nuclear fusing may end up in one of 3 ways. The mature star may eventually expand, collapse, or explode. Low-mass mature stars expand and become intermediate-mass mature stars. Scientists think that our own Sun, which is low-mass, will eventually become a red giant, a dying star in the last stages of stellar evolution. An intermediate-mass mature star tends to collapse under its own gravity, becoming a white dwarf. White dwarfs are incredibly dense stars. Their volume is about that of Earth, but their mass is comparable to that of the Sun. Like low-mass mature stars, high-mass mature stars also tend to expand, but they become massive mature stars. A massive mature star tends to eventually explode in a supernova. Supernova release numerous chemical elements into space, including some that end up on Earth, like gold and uranium. Let us now model together an alternative, more compact and less detailed way to represent this entire system, which does not require the additional OPD called SD1. To do this, we use execution path or simply path. Back to SD, we first remove the procedural links between mature star nuclear fusing and the 2 objects mature star and stellar remnant. We apply specialization unfolding to both mature star and stellar remnant. We do this by copying the 4 specializations of mature star from SD1 into SD and connecting them to mature star with generalization specialization links. We do the same for the 2 specializations of stellar remnant. Now we can show how each type of mature star becomes another type of star, either another mature star or a stellar remnant. First, we connect low-mass mature star with a consumption link to the process mature star nuclear fusing. We then connect this process to intermediate mass mature star with a result link. Now we connect intermediate mass mature star to the same process, mature star nuclear fusing, and this process to white dwarf, again using consumption and result links, respectively. This looks good on first sight, but inspecting the model closely, we spot a problem. How can we tell that low mass mature star becomes intermediate mass and not white dwarf? To resolve this, we add to the first pair of consumption and result links the path label low mass to intermediate star expansion. Similarly, we add to the second pair of consumption and result link the path label collapsing. Great! Our problem is solved because now we can follow the path labels such that we exit the process with the result link that has the same path label as its consumption link counterpart. In a similar fashion, we add two more such pairs of consumption result links. The first is from high mass to massive mature star with path labels high mass to massive expanding. The second is from massive mature star to supernova with path labels exploding. This model expresses almost the same information as the previous model without having to use SD1. The specialized processes are expressed by the tag labels. However, in this model we lose some details as we do not have the specializations of mature star nuclear fusing, which are similar but still different from each other. The path labels could well be just A, B, C, etc. They are not really processes. Rather, they are tags that enable us to express and follow threads of execution passes. Here comes Hopcat to define things for us.
Path, a series of two or more consecutive procedural links. Path label, a label attached to all the links that belong to the same path.
I guess you may feel that your head is exploding from thinking about bursting stars. So take a rest and enjoy the rest of your trip.